Okay, good morning everybody, welcome back. So today we're going to start covering a couple of sort of cleanup topics that I want to talk about before we finish. I only have you for a few more weeks. And when we started, I promised that I would try to teach you as much about Java as possible. In particular, I would try to get you to the point where you'd seen as much of the common Java constructs as you'll need to sit down with a file containing unfamiliar code and read it from start to finish. And so today what we're going to do is we're going to talk about exceptions and errors. This may be something that you've started to notice when you've looked at some of our code or some of the code on some of the Android libraries we're using or some of our starter code or whatever, but we haven't really talked about it officially, and so today we're going to do that. We're going to talk a little bit about what to do when things go wrong. So we've also been focused up to this point on teaching you how to write good code. I haven't wanted you to make mistakes, but there have been a couple of times this semester where we've encountered this sort of situation that's made us a little bit uncomfortable because we haven't had a good way to deal with it. So here's an example. So I think we talked about this type of class like a couple of months ago. You don't really need to know too much about what it's doing, but this is an object that's designed to store strings. And the constructor takes an argument that indicates how many strings am I supposed to store. That argument is an integer. But there are values that I can pass to this constructor that don't make sense. So for example, there's no point in creating this class if I'm going to configure it to store 0 strings. It's useless. Worse yet, if I pass a negative value, what does that mean? So we have a case here where what am I supposed to do? I can write this condition, I can check for it, but what am I supposed to do now? This is made worse by the fact that if you remember, constructors can't fail. A constructor has to return an instance of the object. And so I can leave this object unconfigured, and I can, you know, maybe not set up the storage it needs or whatever, but what I really want to be able to do here is signal to the caller, signal to the code that has tried to create a new instance of string storage that you done wrong. You messed up. This is not correct. You've passed an invalid value to this constructor. So here's one example of this. Here's another using a function. So this can happen in constructors, but it can also happen inside code that we write. So in this case, this function, this is a dumb function because it's duplicating code that already exists, but this function is supposed to take a string that contains an integer value. It contains characters that I can decode into an integer. It's passing it to this static function that's part of the integer class that's supposed to be able to parse that. But what do I do if you've passed me a string that is not parsable as an integer, something like foo, or just a string of characters that I can't parse properly? So here's another example. What am I supposed to do at this point? This is your fault. Someone called this function with a bad argument, but my code needs to be able to figure out what to do to handle this kind of situation. Okay. So Java's mechanism for doing this, and this is an old construct. It's kind of our last block-based construct that we really haven't talked about so far in Java, is something called try-catch. This is Java's exception handling mechanism. It's not that different. In fact, we're going to show you a couple of examples of other languages that use a similar mechanism. But there's some kind of interesting things about how try-catch works that are also going to sort of bring us back and help us think a little bit more about flow through our code, right? Particularly the call stack as one function calls another function, calls another function. All right, so this is the control structure that I use for handling exceptions. So there are two blocks to this, two main blocks. The first one is a try. So you'll see there's a try statement, and then I open up a new block. And in here, I have code that could potentially cause an exception. And you'll see that there are cases where Java, the compiler, will actually require that you use this construct if you're calling a method that can potentially throw or generate an exception. Down here, I have a catch statement. And what the catch statement is going to do, this is kind of a nice pair of terms. The catch statement is going to catch any exceptions generated in the try block. And you'll see in a minute that I can have multiple catch statements that catch different kinds of exceptions. So one thing that I want you to note, and we'll do some examples later in class to drive this home, this is sort of like return. As soon as any of the code inside the try block generates an exception, I immediately jump into the appropriate catch block. I do not continue executing code inside that try block. So as soon as I hit something that generates an exception, I jump into the catch statement that handles that particular kind of exception and begin executing that code. I don't run any more code. Part of the idea here is that these types of errors and exceptions are a surprise. You know, I might have known that they might happen, but I still don't necessarily have a good way of handling them. And so if I write one line of code and then the lines below rely on that code executing properly, if that line doesn't execute correctly, I can't go on. So that's why I jump immediately into the appropriate catch state. All right. So the way that catch works is that the compiler will essentially work downward, and it will try to match the exception type. Exceptions in Java are just objects. So this is very much like other types of type matching we've seen Java do. So for example, if the code that I ran in my try block threw an exception that's of type null pointer exception, or any exception that inherits from null pointer. So essentially, this is sort of like casting, right? If I can cast the exception to a null pointer exception, then I begin that catch block. Otherwise, I keep looking down here. If I can cast that exception into an array index out of bounds exception, which means either it is an array index out of bounds exception or it's a descendant of that particular type of exception, then I begin executing that catch block. I only execute one catch block. I will not do more than one. So I'm going to pick, right, based on the kind of exception, and also based on the order in which they occur. Why I'm struggling with this today. Okay. If nothing fails, then none of the catch blocks are executed, and I continue below the try-catch block, executing code as normal. Okay? Java has a way, if you want to catch multiple types of exceptions using a single catch block, there's syntax for this. So this is kind of a weird bit of syntax, but I have one type of exception, I have a pipe, and then I have another type of exception, and I can string as many of these together as I want, separated by pipes. And then at the, I didn't point this out. Let me go back and do this. So my catch block declares both the type of the exception and then a variable that's going to contain the instance of the exception that was thrown when the catch block starts to execute. So when my catch block starts to execute, the code in there is going to have access to making me all weird. It's going to have access to a variable called E that's going to contain, or it's going to be that's a reference variable that's going to refer to the exception that was thrown in my try block. The reason for this is that frequently my error handling code is going to want to do something with that. That exception, that instance of an exception contains useful information about what happened and could potentially allow me to either display a message or figure out what to do or record some information in a log or something like that. All right, so I can do, again, same thing here. If this catch block gets triggered, I'm going to have a variable called E that's going to refer to an exception that's either of type null pointer exception or a legal argument exception. I'll start executing there. So this is not an unusual construct. I don't know who introduced this. I should have looked this up. I think I read something recently that C++ had this slightly before Java did, but I'm not sure. But I suspect that neither C++ or Java originated this particular idea. But it's a very common one. Error handling using try-catch. These types of constructs exist in Python. So in Python, it's a try-except block. JavaScript has something that's very, very similar. We'll talk about the finally block in a minute. That's another feature of it. But this exists in a lot of other languages. Yeah. Why isn't there what? Yeah, there probably should be. I think I just messed this up, right? Does anyone who write Python code, this should be like value air and then there's a variable over here, is that correct? I think that's right? I just think I messed up the slide. I don't write very much Python code anymore, so. The only thing that's a little bit interesting about Python here, I'll just point this out because we're back at the slide, which is interesting, is that Python actually has an else block that's attached to your try, so you can run code if there's no error. So essentially, I run the try block. If there's an error, I jump into the appropriate except block. If there's not, I run the else block. That's something where there's no equivalent of that in Java. All right, but I don't want to show too much of this at the risk of confusing you. Okay, so let's look at how this works. So the first thing I'm going to do is I'm just going to try to run this little snippet of code. And one of the things you're going to see immediately is that it won't even compile. So we're going to talk in a minute about 3 different types of exceptions and errors that can occur in a Java program. But in this case, the compiler is telling me the following. So remember, another good chance for us to review some of the concepts from earlier in the semester. The compiler is trying to help you out as much as possible. So the compiler is using information in your code to try to make sure that you are handling things safely. So let's go through this, and we'll see what we've told the compiler and why the compiler is reacting this way. So up here on line 3, you've declared a function called throwRandomError. And the other thing you've done here, and this is part of Java's exception handling mechanism, you've declared that this function can throw an exception. That's now something else that we're going to see that's part of this syntax. It's at the end of the function declaration. So what you've told Java is, I'm going to declare a function. It's called throwRandomError. It takes no arguments. It returns an int, and it can throw an exception. And this is a type over here. I could say throws null pointer exception. I could say throws illegal argument exception. I can tell you more about the kind of exception that's being thrown. Exception is a general purpose exception. It's the parent class of many other Java exceptions. So essentially what I'm saying is that this function can throw lots of different types of exceptions. But I've told the compiler this. And so down here, when I try to run this function, what's happening? The compiler is saying, you have told me that this function throws an exception. You've also not handled that exception. So you're calling that function here, throwRandomError, but you have not called it inside a try-catch block. So what happens if that function throws an exception? You're not prepared to handle it. So what do we need to do to get the compiler to quiet down and be able to run this code? We need to wrap this in a try-catch block. I'm going to say try-catch, and I'll say exception E. Let's just print off the exception. Exceptions in Java are objects, like everything else in Java, almost, except those primitive types. So what's this code going to do? So now what I'm saying is I'm going to try to run throwRandomError. If it throws an error, I've declared a catch block here, and all I'm going to do is print off the error that it throws, if it throws one. So let's see what happens. Okay. So now, every time I run this, I'm going to, depending on, I've got a random variable in there that's causing me sometimes to go down this path and sometimes to go down this path. So if I go down this path, what kind of exception am I generating? Well, I'm taking a reference variable of type object, I'm setting it to null, and then I'm trying to call one of its methods. So that's going to generate a null pointer exception. That's what I see right here. If I go down the bottom of the else statement, what's happening? I'm declaring an integer array, but it's empty. It is size 0, and then I try to pull out the 5th value, the value in index 4. So this is also not going to work. Yeah? Yeah, yeah, it's a good question. The question was, is exception E acting here as a catch-all? Essentially, it is. So here's what happens when this runs. If I go down the top of the if-else statement, the code throws a null pointer exception. Java starts looking down here and it says, what part of the catch statement is going to catch a null pointer exception? So it tries the first block. It says, can I cast a null pointer exception to an exception? And you can, because a null pointer exception is a subclass of exception. And so that matches. If I throw an array index out of bounds exception, because I went down the bottom of the else statement, then I'm gonna end up again at line 17. Java's gonna say, can I cast this to an exception? The answer is yes, and it's gonna run that code again. So yeah, that's gonna work. I'll show you an example in a minute where I catch these separately. Yeah? So yeah, we'll come back and talk about this in a second. So the question was, are there exceptions I can't cast to exception? So exception in Java is the parent class of all exceptions. There is exception itself is a descendant of something called a throwable. And we'll talk briefly about what that is. But there's kind of one more level above that, right? A throwable is anything that can be thrown out of a try statement, right? And that includes both exceptions and something called an error. Errors are much more serious problems in Java. They're not things you're expected to handle. But we'll talk about the distinction in a minute. One thing I want to point out here, just to remind you, is that this code will always throw an exception. You'll see that regardless of whether or not I get true or false here, I'm going to either do the top part of the if, which throws one type of exception, or the bottom, which throws another. The code on line 17 will never get executed. You see that, because as soon as I run throw random error, it throws an exception, and then I jump immediately into the catch block. The compiler is also smart enough to help you with this, so let's do the following. Let's say here that I'm going to just catch exceptions of type null pointer exception here. What's going to happen if I try to compile this? Right. So this can be sort of confusing. So the compiler is saying, you're not catching the exceptions. And you're thinking, I am catching the exception. But here's the problem. That function can throw anything of type exception. And you're only catching null pointer exceptions. And so the compiler, again, is warning you, there are exceptions that this code can throw that you are not catching. And so the code won't compile until you fix this. So if I go up here, I could do the following. Let's declare this to throw a null pointer exception and array index out of bounds exception. Now I'm okay, right? Because I shouldn't be okay. Okay. I don't know if this has rolled over to the next line. Let's try this. Let's declare this to throw an array index out of bounds exception. Okay, so now I have a problem, right? Actually not sure why it's allowing me to even compile this code, because I'm only declaring that I'm catching a null pointer exception. Oh, I know why this is. Sorry. Well, this will make more sense in a minute. This is a bad example. Let me go back and just return to saying that I'm throwing an exception. All right, so again, compiler is helping me. It's saying I'm not catching all the exceptions that you can possibly throw. All right, questions about this before we go on? I apologize for muddying the waters a little bit with that example, but that'll make a little bit more sense in a minute. Okay. So one of the things that can be difficult to understand about exceptions is what happens when they are handled. Because, you know, until now, we've had this very linear, very comfortable model of Java execution where I execute a line of code. If that line calls a function, I start running the function until the function returns, and then I continue running the function that called that function, just sort of one after another. I might have a loop that I go back to the top. I might have an if-else statement that I execute only one block of, but we're pretty comfortable with this so far. When exceptions get thrown, more interesting code flow can occur. So for example, what Java will do when an exception gets thrown is that it will throw that exception up the, we saw this up the call stack. So if the function that called, if the function that you can generate, you can handle the exception right there, right, with the try-catch statement. If that function declares that it's thrown, Java will look in the function that called it. If that function that called it didn't handle it, it'll look in the function that called it, and it will keep doing this until it finds a catch block. This is probably easier to show you here. So what's happening here? So I've got a function called foo4. Foo4 is calling foo3, which calls foo2, which calls foo1, which generates an exception. So this is going to, again, do the same dumb thing we did before. I create a reference variable type object, set it to null, and then try to call a method on it. That's not going to work. It's going to generate a null pointer exception. What's going to happen next? So foo1 is what generated this exception. But I'm going to look up in foo2. Does foo2 catch the exception? Well, first of all, is the exception caught right here? Is this code inside a try-catch block? No. I'm going to look in foo2. Does foo2 handle this exception? No. Then I'm going to look in foo3. Does foo3 handle this exception? No. Finally, I get all the way up to foo4, and I find a catch block. And so that's the next line of code that's going to execute. Even if there's other code inside foo1, foo2, and foo3, as soon as an exception is thrown, Java begins throwing that exception up the call stack from the function that I'm running in to the function that called that function to the function that called that function, all the way until I find a catch block. Or, in certain cases, until I don't find a catch block and your entire program crashes. So that can also happen with exceptions. So again, here's a example here. So let's put code in the handler. And let's put code here just to print off what's going on. Same thing. And I'll put one printf here. And you'll see that the only thing that gets printed is foo4. So when I ran foo4, I've put this off the bottom, but all the way down to here, what happens is I start foo4, I start running foo4, foo4 calls foo3 in a try-catch block, foo3 calls foo2 not in a try-catch block, foo2 calls foo1 not in a try-catch block, foo1 generates an exception. That exception propagates all the way up, starts in foo1. Java says, is there a try-catch block here? No. I'm going to look at the function that called foo1. Is there a try-catch block around the function call? No. I'm going to look at the function that called that called foo2. Is there a try-catch block here? No. I'm going to continue going. I'm going to look at the function that called foo3. Okay, I found some code that can catch this exception. So Java will look in all of the function, essentially across the entire chain of functions that I called to get wherever I am, to look for something that can catch this. Now, as soon as I catch the exception, usually I'm done. So think about what's going to happen now. So let's put a try-catch block here. Well, actually, you know what? Let's just handle it silently. Okay, so now what's happening? So now I run foo4, which calls foo3 inside a try-catch block, which calls foo2, which calls foo1 inside a try-catch block, which generates an exception. Throws an exception. But that exception is now handled immediately inside foo2. Foo2 catches the exception. I can have an empty catch block. You generally don't want to do this. When an exception happens, you're usually going to do something special to handle it. But for the purposes of this example, let's just leave it empty. So this empty block is executed. Java says, okay, we must be done with the exception now. It's been caught. And then I execute foo2. Foo2 finishes, foo3 then finishes because it called foo2. And if I put a printf down here, let's put this outside the try-catch block, I'll see that too. Questions about this? Again, this is one of the gnarlier bits of this particular mechanism. Yeah, Jeremy. No, the try in foo4 is never executed. You'll see here that, you see this printf? Because by this point, the exception has already been caught. Right, so the question was, does the try in foo4 succeed? Oh, I'm sorry, yeah, the try statement succeeds. This doesn't throw an exception, because the exception has already been caught up here in foo2. I'm just gonna pause here for a minute, see if there's any other questions about this. Because again, this is the path that your code can start to take once you start catching and throwing exceptions is different than you're used to because of this mechanism. This is a new type of code flow, right, that we have not seen before. Okay, let's keep going. So the kind of exceptions that happen in Java can be broken into roughly 3 categories. And you're probably, you know, as a Java programmer, you're probably gonna spend about, I would say, particularly once you get to be a good Java programmer, about, I don't know, 60% of your time on the first kind, 39% of your time on the second kind, and 1% of your time on the third kind. Right? So we're gonna spend about that much time here today as well. The first category of exceptions are what are called checked exceptions. The idea behind a checked exception is that you know that something can potentially go wrong. It's outside of your control. It has to do with, like, the environment, maybe it has to do with the user, right? It's possible that your program can receive an incorrect input, or something bad can happen, like the network might go down, or a file that you tried to open might not exist, or something like that, right? So you're aware of the possibility that there is an error, and you are planning a way to deal with that problem, right? So this is what a checked exception is. Checked exceptions are usually declared to be thrown by a function, and again, as a programmer, what you're doing is you're preparing for a problem. You're aware of the fact that a problem might occur. You're writing code to prepare for it if it happens. So unchecked exceptions are sometimes referred to as runtime errors. These are unanticipated problems. So in the first case, we're anticipating that something might go wrong, and we're gonna do some work as the programmer to prepare for that. In the second category, you are not anticipating that something could go wrong because usually these are the result of something dumb that you did. You messed up. You walked off the end of an array. You have a reference and you didn't check it for null, and then you tried to do something with it. If you had anticipated these, you probably would have written your code differently. You would have checked for null. You would have not walked off the end of that array. You would have adjusted the for loop bound so that that didn't happen, right? So these are almost always the result of programmer error. And then the final case are errors. And this is Java's terminology, not mine. You might think that these are all errors, but a Java error is a serious problem with the system or with the Java runtime. These are not recoverable typically. These are like you're out of memory or something of that sort. Right? These are serious problems. Sometimes they're caused by you, right? So for example, if your program runs out of memory, you might redesign it to use less memory. A Stack Overflow error is an error that can fall into this category. Some of you have seen that one recently. That is caused by you. Typically, you have some sort of recursive function that doesn't have a base case or doesn't reach the base case. So sometimes these errors are caused by your code, but they're also not recoverable. Usually by that point, the only thing left is for Java to crash. They'll tell you a little bit about what happened so you can fix it, but there's no way to kind of work around these. All right. So let's talk about checked exceptions first. Again, this is probably the category that's the most important to understand as a Java programmer, someone who's gonna write code that deals with errors. So typically, again, these are cases for where there's some sort of failure in the universe that's going to affect your program. So here's some examples. Your file tried to open a program, your program tried to open a file, and that file didn't exist. Maybe that user moved something on you and didn't tell you about it or something. So here's one example, right? I needed to open a file as part of my program. That file wasn't there. So we'll look at this an example. I just pulled some random examples from code that I was familiar with. You tried to parse. So there's something called a URI that's used on the internet. URLs are a subset of URIs. This is an identifier that has a particular kind of syntax. It's a string that identifies a resource that I can use. But if the string doesn't have the right syntax, I might get something called a URI syntax exception, we'll see an example of this in a minute. So, and here's here is the example. We'll see it right now, I guess, right? So, and this is an interesting chance for us to look at the hierarchy here. So, before we said that exception is the parent class of all Java exceptions, and we can see here that java.net.uri syntax exception inherits from Java lang exception. Java lang exception itself inherits from Java lang throwable, so there's that one level of additional hierarchy there, because there's both errors and exceptions that fall under throwable. And then, of course, everything inherits from object. And so this is, and like I said before, I want to emphasize this because it's something that's kind of nice about Java. In Java, errors are objects. Exceptions are objects. And so they have properties. They have methods that you can call, right? You can return them from a function. Like you can create your own that inherit from existing ones and customize their behavior, right? They fit seamlessly into the rest of the Java object model. So as I just showed you a few slides ago, oh, sorry, yeah. Universal Resource Identifier. Yeah. Yeah, let me come back to that in a second. So the question was, are we gonna talk about these unchecked exceptions? Yeah, we'll talk about that in a minute, once we get done with the checked exceptions, right? So, checked exceptions are thrown in Java in places where the code or the library is aware that an error might occur. So for example, if I'm writing the java.net library, and I have some code that parses a URI, or a universal resource identifier. If the string that you gave me is like gobbledygook and doesn't have the right format, that code is going to throw a URI syntax exception to tell you, the programmer, somehow, I don't know how, maybe it's the user's fault, maybe it's your fault, you passed me a string that does not contain a valid URI. I can't parse it. So that code's gonna throw an exception, and if you use that library, you now have to potentially handle it. So if you call a function that throws an exception, you have to do either one of two things. You can either wrap it in a try-catch block, which means that you are going to handle the exception, or in other cases, you can declare that the function that you're writing also throws that exception, which essentially means sort of like passing the buck. You're now saying that if you call my function, you have to deal with this problem, right? So you can do two things with a checked exception. You can handle it, or you can declare that your function throws it, and then someone else, somewhere else who uses your code is going to have to handle it. So those are your two options. So here's one of them. Here I'm creating a new URI that can generate a URI syntax exception. All I'm gonna do here is complain, right? I'm just gonna print something to the console and say, bad code, this is not a good URI. Usually you want to do something a little bit more sophisticated than this. Or, if I don't want to handle it, sometimes I don't know how to handle it. Sometimes this isn't the right place to handle this problem. In that case, I can throw it. So now I'm allowed to call the constructor to create a URI and pass it a string. This constructor generates this exception. Now I'm allowed to call that constructor, but in order to do that, I've had to declare that my function can now throw a URI syntax exception. All right, so here's an example with the URI. I have to either say throws URI syntax exception. Is it exception or error? I think it's exception. Nope, URI syntax error. Oh, I have to import it. All right, java.net.uri syntax exception. So let's get this into my namespace, and then we'll do syntax exception. Right, so now, so again, I can pass the buck, but I still have to handle it somewhere, right? So now if I wanted to run this code, now I have to put my try-catch block out here. Because now the compiler is saying, you're still not handling error anywhere, you know, you have to do that. You can't just ignore it, right? So now I can do it, and now let's put something in that isn't a valid URI. I guess that is a valid URI. Let's do, let's see about something like that. Is that a valid URI? Let's try this guy. Oh. And I'm having a hard time with this. Let's try this. Pretty sure at some point I had a way of doing this. Let's try this guy. There we go. I had to give it something that looked like emoji before it would really throw up its hands, right? Okay, so finally, right, apparently this is not a good URI. Like, something that starts to be looking like shruggy is not okay. Alternatively, so again, I can either throw the exception out of the function, or I could put that try-catch block in here. Let's say try, let's do this. D. And now here, you know, this is one of those things where we have to start thinking, what should I do? Like, what should I do if something goes wrong? Anyone have any ideas? This function is supposed to return a URI. Could I do? I mean, you know, again, error handling isn't always simple, right? What might I want to try here? Yeah, so, yeah, I could do that. I could basically say, I'm gonna give you a URI that I know works, right? As a default. If I was doing this on Android, I'd probably want to put some logging in here, right? This is a good place to put an error message. And this is not gonna work, obviously, because it's not on Android. Received a bad URI. And then I would log the string or something like that. Because again, it depends. If this is coming from another place in your application, then you have a problem. If it's coming from the user, then you might want to display a message here and say, you know, that's not a valid URI, please enter something else, or something like that, right? How we handle the error is really dependent on the application we're writing. But those are our two options, right? Again, this is not gonna. Why is it mad at me now? Oh, there we go. Man, I'm struggling today. There we go. Yeah, so now you can see what happens, right? So essentially, if I try to create an invalid URI, I just hand you back something that I know works, right? I could return null. Again, I could flash a message, right? But in general, the error handling strategy depends a lot on what I'm trying to do. Okay. So let's talk about the next category of exceptions, which are unchecked. So a checked exception, somewhere in the code, there's a throw. And then I design these catch blocks somewhere in my code to handle a potential error. Unchecked exceptions are much harder to anticipate because, again, they're typically the result of a mistake on your part or on someone else's part, your partner's part for the final project. I'm sure all the errors in your project will be your partner's fault. So that's always how it works, right? All right, so in this case, I'm not necessarily gonna use the same try-catch mechanisms, right? Because I can't anticipate the problem, right? If you knew that you were gonna dereference null, you would fix the problem. You would check for null. If you knew you were gonna walk off the end of the array, you would fix the for loop, right? Here are some examples of these that you have probably met. I suspect that many of you, if not all, have generated most or all of these exceptions. Maybe not all of them. Array index has you walked off the end of an array, right? Null pointer. You had a reference and there was null and you dereferenced it. This is a fun one. Class cast exception. When does this happen? You guys have done more with casting and inheritance that we had in the past. I suspect you guys have seen this as well. When does this happen? Well, we'll come back and talk about this. But typically, what you're doing is you're doing a downcast. Remember, upcasts, the compiler will allow you to do safely. It'll check them for you. A downcast, you know, you're telling the compiler, I know this is safe. If it's not, this is what's gonna happen. At runtime, you're gonna have this class cast exception. A legal argument exception, you've passed arguments to a function that it doesn't support, right? All right, so let's have some fun with this. Let's see if in a few minutes we can generate all of these different kinds of exceptions. So let's get the easy ones out of the way first. So we'll say, let's create an array. This requires that I be able to type. And then I'm gonna dereference array 4. It doesn't like this. Need to do something with it, so I'll print it. Uh-oh, okay, so what happened, here's an example of this try-catch syntax where I catch one type of exception after another. One thing I want to point out here that's different, and this is why we got into a little bit of trouble with that earlier example. Falter does not declare that it throws any exceptions. Did you notice that? It is throwing exceptions, but they're not declared. Why are they not declared? Because these are unchecked exceptions. If I declared that it threw an array index out of bounds exception, just fix the problem, right? Don't declare that your code throws it. So essentially, I'm allowed to throw these unchecked exceptions without declaring that I'm going to do that, because they happen because of these kind of mistakes, right? So again, I don't put static falter throws array index out of bounds exception. It could still happen because my code has a mistake. All right, so let's do a couple more examples of these. Object will be null is equal to null, be null dot hashcode. A little bit of preview for Friday's lecture. Let's print off this. Is that gonna work? No, it's not. What happened when I handled it? Java said, is this array index out of bounds exception? No, it's a null pointer exception, so I ended up in this block. Okay, let's do some of the more fun ones now. Let's create a new object. And then, let's say string s is equal to string will be null. Now, a class cast exception. So this is a forced downcast, right? I have to use an explicit cast here on line 5 to force this object into a string, but it's not a string. And so unfortunately, the compiler can't check this for me at compile time, or what the compiler would do is it would say, by the way, on line 5 there, you're doing something dangerous. I hope that you know that that's really a string reference that you're trying to cast. And of course, in this case, we're wrong. Right? So this is my cast exception. A legal argument exception. This one is a little tricky because I have to call a function, right? But it turns out that I know a function that's going to work here. So, and this will be a nice coda to our sorting lectures, right? So, in case you need to sort something in Java, please do the following. That is how you do it, right? Don't implement bubble sort. Just call arrays.sort. That'll sort this array for us. Normally that will just work, but arrays.sort will also allow me to sort part of the array. So it'll take a start and an end. But what happens if my start is greater than my end? So now I'm doing something that's pretty counterintuitive. I'm essentially asking the arrays class to sort this array, but start at index 1 and end at index 0, that doesn't make any sense, right? And if we look, and I wish I had the arrays documentation up, if you look at arrays.sort will declare that it will throw an illegal argument exception. Now again, because illegal argument exceptions are unchecked, I don't have to declare that I'm gonna throw them or wrap it in a try-catch block, because again, this is a mistake on my part, right? This is not something that happened in the world that I'm trying to deal with. The right way to fix this is to change my code. Okay. So like I said, you don't have to declare that you handle them or wrap them in a try-catch block, but you can handle them, right? So again, if you are concerned about the result of calling a particular function and want to make sure that it's sane, you can do things like this, right? You know, this will catch a null pointer exception properly. Right? You could also just check it for null, but this will do the right thing. I'm going to show you in a few slides how so you might think, well, why not just check for null here? Why not just say if s equals null, you know, send angry email to partner? I'll show you the reason for that in a minute. There are times in which wrapping a bunch of potentially unsafe code in a try-catch block can actually result in code that's a lot cleaner and easier to read. There was a question a few minutes ago on, I think it came from the balcony, on why when your code fails, sometimes you see this unchecked exception, right? And so here's the reason for that. So typically, what you do when you guys write bad code is that it's the equivalent of running falter without the try-catch block. And so now what happens? So my call to falter on line 9 is safely wrapped in a try-catch block. So that means that I'm going to handle any errors that occur. My call to falter on line 7 is not wrapped in a try-catch block, and it still generates an exception. So here's what happens when this code runs. Java runs it. It says it threw an exception. Is there any code that handles this? No. And so eventually, unchecked exceptions, if they are not caught, will bubble up all the way to the point where they cause the Java interpreter to crash. And when it crashes, it'll print off some nice message for you about what went wrong, right? So again, if I go forward and I look at this next piece of code, if I didn't wrap this in a try-catch block, it's still, you know, it'll have the same problem, right? What'll happen is that my program will crash, right? And Java will print off some message about what went wrong. Okay, almost to the end of this. 30 seconds on errors. Errors are serious conditions that are not recoverable out of memory errors. There's one example, Stack Overflow errors. Note that, again, as I said before, these are sometimes still your fault, but the point is that there's nothing to do. By the time you've run out of memory, it is too late to save anything. By the time you have overflown the stack, it's too late. Java is going to crash. It'll tell you a little bit on the way out, but there's no point trying to handle these things. They're just going to cause the interpreter to crash. Right? Okay. So let me finish up today by just talking about a couple of strategies for handling different kinds of exceptions. So errors, you got nothing. There's no point even trying. Just give up. You're not going to be able to handle it. Unchecked exceptions, like we've been saying, are typically your fault. Fix your code, right? That's the way to avoid these. These are always the result of either not following directions, not calling a function with the proper arguments, or just stupid mistakes. You forgot to check for null, you walked out the end of array, things like this. As a programmer, I just want to warn you about something. Maybe this is going to depress you and cause you to give up your dream of going into computer science. But you will never stop making these sort of dumb mistakes. The only thing will happen is you'll get better at fixing them rapidly. I still make them all the time. Not as often as I used to, but still often enough. Checked exceptions, these, you know, we're not going to talk about exceptions at length, but typically what to do depends a lot on why something went wrong. If the user gave you some bad input, pop up a message and say, hey, by the way, this is not a valid whatever. Please try again. The wrong thing to do here is to crash, right? Usually with checked exceptions, you can handle them in a graceful way that allows your program to continue running and continue accepting input, continue working. Okay. So I'm going to stop here. We'll pick this up on Wednesday. I just have a few more things to cover before we're done, but we're very close. There's a couple of announcements. Keep in mind, the final project is up. You guys have a checkpoint in a week, so please get going on that. I do have office hours today at 10 o'clock, assuming that I don't freeze on the way to Siebel. I will see you guys all on Friday. Good luck on the quiz.